In this video, we will describe and show inside ice cream factory and the manufacturing production line. The production of ice cream and includes the legal ice cream definitions, ingredients, and general ice cream manufacturing procedures. Ice cream is a frozen blend of a sweetened cream mixture and air with added flavorings. A wide variety of ingredients are allowed in ice cream, but the minimum amounts of milk fat, milk solids, and air are defined by standards of identity in the U.S. Code of Federal Regulations, CFR, for ice cream, goat's milk ice cream, and for sherbet. Ice cream must contain at least 10% milk fat and at least 20% total milk solids, and may contain safe and suitable sweeteners, emulsifiers, and stabilizers, and flavoring materials. The finished ice cream must weigh at least 4.5 pounds per gallon, and there must be at least 1.6 pounds of total solids, which are fat, protein, lactose, minerals, and added sugar, per gallon, thus limiting the maximum amount of air, called overrun, that can be incorporated into ice cream. There are well-defined labeling requirements for the types of flavors used, natural or artificial, and for the presence of egg yolks in the finished product. Ice cream can be called custard or French if the content of egg yolks is at least 1.4%. Ice cream is sold as hard ice cream or soft serve. After the freezing process, only a portion of the water is actually in a frozen state. Soft ice cream is served directly from the freezer where only a small amount of the water has been frozen. Hard ice cream is packaged from the freezer and then goes through a hardening process that freezes more of the water in the mix. What raw materials are used to make ice cream, or ice cream ingredients? There is a wide range of ingredients and formulations, recipes, that can be used in ice cream. Milk fat provides creaminess and richness to ice cream and contributes to its melting characteristics. The minimum fat content is 10%, and premium ice creams can contain as much as 16% milk fat. Sources of milk fat include milk, cream, and butter. The total milk solids component of ice cream includes both the fat and other solids. The other milk solids consists of the protein and lactose in milk and ranges from 9 to 12% in ice cream. The non-fat solids play an important role in the body and texture of ice cream by stabilizing the air that is incorporated during the freezing process. Sources of non-fat solids include milk, cream, condensed milk, evaporated milk, dry milk, and whey. Sweeteners are used to provide the characteristic sweetness of ice cream. Sweeteners also lower the freezing point of the mix to allow some water to remain unfrozen at serving temperatures. The lower freezing point makes ice cream easier to scoop and eat, although the addition of too much sugar can make the product too soft. Sweeteners used include sugar, sucrose, and corn syrups. Stabilizers are proteins or carbohydrates used in ice cream to add viscosity and control ice crystallization. Over time during frozen storage, small ice crystals naturally migrate together and form larger ice crystals. Stabilizers help to keep the small crystals isolated and prevent the growth of large crystals, which causes ice cream to be coarse, icy, and unpleasant to eat. Stabilizers used include alginates, carrageenan, gums, locust bean, guar, and gelatins. Emulsifiers are used to help keep the milk fat evenly dispersed in the ice cream during freezing and storage. A good distribution of fat helps stabilize the air incorporated into the ice cream and provide a smooth product. Emulsifiers used in ice cream include egg yolks and mono and diglycerides. A wide range of flavorings are used in ice cream. Flavorings include natural and artificial flavors, fruit, nuts, and bulky inclusions such as chocolate chunks and candies. General ice cream manufacturing procedure. The following discussion provides a general outline of the steps required for making ice cream. 1. Blend the ice cream mixture. The milk fat source, non-fat solids, stabilizers, and emulsifiers are blended to ensure complete mixing of liquid and dry ingredients. 2. Pasteurize mix. Ice cream mix is pasteurized at 155 degrees Fahrenheit for 30 minutes or 175 degrees Fahrenheit for 25 seconds. The conditions used to pasteurize ice cream mix are greater than those used for fluid milk because of increased viscosity from the high fat, solids, and sweetener content and the addition of egg yolks in custard products. 3. Homogenize. Ice cream mix is homogenized 2500 to 3000 psi to decrease the milk fat globule size to form a better emulsion and contribute to a smoother, creamier ice cream. Homogenization also ensures that the emulsifiers and stabilizers are well blended and evenly distributed in the ice cream mix before it is frozen. 4. Age the mix. Ice cream mix is aged at 40 degrees Fahrenheit, 5 degrees centigrade, for at least 4 hours or overnight. Aging the mix cools it down before freezing, allows the milk fat to partially crystallize, and that gives the protein stabilizers time to hydrate. This improves the whipping properties of the mix. 5. Add liquid flavors and colors. Liquid flavors and colors may be added to the mix before freezing. Only ingredients that are liquid can be added before the freezing to make sure the mix flows properly through the freezing equipment. 6. Freeze. The process involves freezing the mix and incorporating air. Ice cream mix can be frozen in batch or continuous freezers, and the conditions used will depend on the type of freezer. Batch freezers consist of a rotating barrel that is usually filled 1/3 to 1/2 full with ice cream mix. As the barrel turns, the air in the barrel is incorporated into the ice cream mix. Ice cream freezers designed for home use are batch freezers. Continuous freezers consist of a fixed barrel that has a blade inside that constantly scrapes the surface of freezing barrel. The ice cream mix is pumped from a bulk tank to the freezing barrel, and the air is incorporated with another pump just before it enters the freezing barrel. The continuous freezing process is much faster than the batch freezing process. The addition of air is called overrun and contributes to the lightness or denseness of ice cream. Up to 50% of the volume of the finished ice cream, 100% overrun, can be air that is incorporated during freezing. The overrun level can be set as desired to adjust the denseness of the finished product. Premium ice creams have less overrun, approximately 80%, and are more dense than regular ice cream. At the point of discharge from the freezer, draw temperature, only about 50% of the water in ice cream is frozen. Soft serve ice cream is generated at this point in the freezing process. 7. Add fruits, nuts and bulky flavorings, candy pieces, etc. Fruits, swirls, and any bulky type of flavorings, nuts, candy pieces, etc. are added at this point. These ingredients cannot be added before freezing, or they would interfere with the smooth flow of the mix through the freezer. The ice cream at this point is soft, and it is easy to mix in the bulky flavorings, so they are uniformly distributed throughout the ice cream. Mixing in bulky flavorings after freezing also prevents damage to the pieces and allows them to remain whole or in large chunks. 8. Package as desired, depending on the product. 9. Harden. The ice cream is cooled as quickly as possible down to a holding temperature of less than -25 degrees centigrade. The temperatures and times of cooling will depend on the type of storage freezer. Rapid cooling will promote quick freezing of water and create small ice crystals. Storage at -25 degrees centigrade will help to stabilize the ice crystals and maintain product quality. At this temperature there is still a small portion of liquid water. If all the water present in the ice cream were frozen, the ice cream would be as hard as an ice cube. Ice cream and related products can be divided into a number of categories. As legislation varies from one country to another, the following should be regarded as a guideline only. The fat content of ice cream typically determines the category to which it belongs. In some countries, fat content has to exceed 9% to qualify for the ice cream category. Below this level, the product is typically called milk ice, whereas ice cream with more than 12 to 13% fat is often categorized as either luxury or premium. The fat can be either of animal or vegetable origin. If the latter, legislation in a number of countries dictates that the product cannot then be called ice cream, but must be labeled, for example, non-dairy ice cream or frozen dessert. Sorbet is the term used for a frozen, typically fruit juice-based product with a certain amount of overrun. The mix passes through a continuous freezer where air is incorporated. Sorbet products are characterized by fresh eating properties and do not contain fat or milk solids non-fat, MSNF. Due to the high viscosity from the freezers, fruit pieces and other inclusions can also be added to the sorbet product before filling. In order to obtain a final product with more body, ice cream producers also produce sherbet that contains a small amount of fat and MSNF. Sherbet still retains the fresh eating properties associated with sorbet. Frozen yogurt gained enormous popularity in the US during the 1980s due to its relatively low fat and calorie content. Weight and cholesterol watchers were delighted. Typically, a frozen yogurt is a blend of standard ice cream mix and yogurt with live bacteria. Yogurt ice cream tends to have a fresher taste than standard ice cream. Today also Greek yogurt is popular due to the high protein content. Water ice is a blend of sugar, fruit concentrates, stabilizers, flavor, and color. The finished mix is pasteurized and mostly filled into molds or pockets on a rotary or inline molding machine. Freezing takes place in the pockets, which pass through a cold brine, salt solution, freezing zone. When the water ice is frozen, it is extracted from the pocket. Water ice sticks are typical children's products, and great varieties in color and flavor are quite common. Combinations together with an ice cream core also make the products appealing for adults. The development of extrusion technology has created a new category known as extruded water ice. Basically, a water ice containing a whipping agent is pumped to the continuous freezer, where air incorporation and a significant part of the freezing of water takes place in the continuous freezer cylinder before extrusion. The final product typically contains 20 to 30% air, is very fresh, and has a clean flavor release.